Hello, welcome to Mahr's March Product of the Month webinar. Today it's PocketSurf 4, our portable roughness measuring instrument. Hello everyone. I'm your presenter, George Schutz, Director of Precision Gauges in Providence, Rhode Island. And if any time during the presentation you can use the chat feature to ask any questions that you might have, and I will respond to your question after the webinar by email. Again, thank you for your participation today. Today we're going to learn about the PocketSurf 4, our mobile surface measuring system. We'll discuss a little bit why we measure surface finish, what surface finish is, and what is the PocketSurf 4. We'll talk about some of its features, the accessories available for the PocketSurf 4, applications where you can use it, why you might need it, and then we'll go over the great value of the product of the month. Now, why is it important to monitor surface finish? Well, as you can imagine, products for aerospace, electronics, automotive, all the precision manufacturing, there's been a revolution since the 1940s and 50s where tolerances have become tighter and tighter as higher and higher performance is required. So as dimensional tolerances tighten, form and surface finish errors become more significant. So every surface has some function, and unless it is measured, one will not know if that product will perform as it is desired. So you can see this chart on here represents how tolerances have gotten smaller and smaller since the 1940s and 50s. And even a small form or surface finish error can be a big percentage of the tolerance and affect how that part performs. So it's important to monitor surface finish these days. Now, why is it important to control surface finish? Well, surface finish affects a lot of parts of the part itself. The most obvious is appearance. Surface finish affects the reflectivity light and consistency of the part. So you can see on this picture on the right, we have a pretty reflective surface and a rather dull, non-reflective surface. All of that is created by having different surface finishes. Surface function is another important reason for monitoring surface finish. Think about painting a surface. If that surface is too smooth, maybe the paint won't stick to the surface or adhere to the surface. Or if the surface is too rough, the coating may not coat it properly, and the rough edges will protrude over the coating. Also, surface interaction is an important reason for monitoring surface finish. Slotting surfaces should be smooth to reduce the friction of the two parts. So you might want to have a very fine surface finish, but maybe you want to create a surface roughness that actually has some grooves for oil to fill in, thus allowing the surfaces to become lubricated and move smoothly against each other. Also, it's a way to maximize machining processes. It can allow you to fine-tune the speeds and feeds of a machine tool to produce a target surface finish, so you're not over machining or under machining the part, and also allows you to analyze problems with the machine. Maybe the machine is out of square, or the tool bits are loose or something that can be picked up by monitoring the surface finish. Now, surface finish comes from the manufacturing process, and you think about a lathe, for example. It has a cutting tool, it has some bearings turning the spindle, it has a pulley, it has a motor and gearboxes and so forth. And all those parts of that that machine really can imprint themselves onto to the part that's being machined. So the roughness will come from the tool marks. Vibration can cause a waviness type of layment onto the part. Straightness comes from the form characteristics of the machine. And when you put all those together, you get a total profile of what that surface might look like. So most machining processes produce these three elements, but roughness is the one that's probably the most influential. Now, we've been measuring surface roughness for a long time, but we haven't been doing a very good job in the very beginning. You know, we had scratch standards and people were using their fingernails to get an estimate for how good the surface would perform. Well, that's a good start, but people just don't measure things the same way using those techniques. So today there are some very sophisticated methods for the measurement of surfaces. Most of them use mechanical contact, but there's been some pretty good breakthroughs recently for optical measurements that can really correlate very well with a mechanical contact system. But most surface finish are done with contact methods, and the most common one is the skidded measurement system, where you can see here where we have a probe that's driven by a drive unit. That probe has a skid on it, and actually the skid rides on the surface of the part, and a small probe contact protrudes through the skid to actually measure the roughness characteristics of the part. So this type of system only measures roughness. The waviness and the other profile information is all taken out because the skid filters that out. A skidless system allows you to see the roughness, waviness, and profile, where a precision straightness datum built into the drive system moves the probe back and forth over the sample being tested. So the reference datum that's in the drive is actually what the surface finish is compared against. With this type of system, you can measure the waviness and profile besides the roughness of the part. So Mahr provides both types of surface evaluation measuring instruments. Most of the portable roughness instruments use the skidded measurement technique, but Mahr does also provide a skidless portable measuring instrument. Now, when you look at surface roughness, there's really nearly 100 parameters that can be used to evaluate surface finish. And they serve different functions for checking the stability of the manufacturing processes, functional characteristics of the surfaces. You can use these parameters to look at the analytical capabilities of the instruments. So there's lots of different parameters out there, but most things come down to what the average roughness is, and the most common parameter is roughness average. And since the roughness profile contains peaks and valleys, this averaging method is most commonly used to qualify the surface. It gives us a good general indication of what the surface is doing. It's easiest to understand and visualize. You can easily quantify it with a single number. So for example, if somebody asks you what the surface finish of that part is, well, you can very easily tell them that the roughness average is 75 microinches. And people can understand that. The higher the number, the rougher the surface. The lower the number, the smoother the surface. So it's a good way of quantifying the surface roughness. But you can use that parameter and measure a number of different surfaces, you might get the same result, but the surface, if you really looked at the profile, can be completely different. So you can see that these two surfaces, if you used a roughness averaging method to measure them, they could give you the same result, but you can see that their function could be completely different. The one on the left probably isn't a good bearing type of surface, or the one on the right might be a little better for that. So RA is often specified, and it's a valuable way for monitoring the process stability, but there may be other parameters out there that can be used to monitor the actual surface function. But RA is by far the most commonly used parameter. But let's talk about the March product of the month, the Pocket Surf 4. Now, people have been measuring surface finish for a long time, and the common practice was there was a lab in the back of the plant somewhere where people might take their part to a very sophisticated surface finish test equipment, make the measurements back there by some highly skilled technicians to get the roughness average. Well, a lot of time was lost in that process. Now, today, there are portable devices that can be brought to the point of manufacture, and now surface finish measurement can be done right where the machining process is, and people can get immediate results. They're fast and easy to use, and you don't have to be a skilled technician or a quality control person to use these portable surface finish devices. So the Pocket Surf 4 is a pocket-sized, economically priced, completely portable instrument. It can be used portable by itself, or it can be bench-mounted. It performs traceable surface roughness measurements on a wide variety of surfaces. It can be used in production on the shop floor, or you can use it in the laboratory. It's really meant to be used at the point of manufacture. And this is shown by its durable cast aluminum housing, so it can provide years of reliable surface finish measurements. You don't have to worry about things becoming loose, plastics becoming cracked or anything like that. This is a cast aluminum frame that really solidifies the measuring system. Now, the Pocket Surf 4 isn't something new. It's been around for many years. In fact, the first Pocket Surf was introduced in the mid-'80s. And you can see here's a picture of an old catalog. It was really the first self-contained pocket-sized surface finish system. There were other devices around at the time. They were quite fragile. They had cables between the drive and the display unit. And you really had to be careful with the probing systems because they were so fragile. But the Pocket Surf really packed surface finish measurement in a robust package that was really meant to be used and make surface finish measurements at the point of manufacture. It really became, since the 1980s, the standard of the industry for measuring surface finish at the point of manufacture. The first one only provided RA, and you can either choose the results in either micro-inches or microns. But it had some pretty important features that we will see continue today. It had a simple one-button operation. You can choose micro-inches or micrometers. It had a large, as a product, the easy to read LCD display. And what was unique at the time is that the probe could be positioned to 4 separate orientations to really increase its versatility. So you can use it straight on, you can use it self-contained, you can have it pointing at the 90 or 270-degree position for lots of versatility. And you can see the picture here of measuring on the crown of a crank the surface finish. So it provided lots of different capabilities, things that were unique at the time. Then in the late 90s, Pocket Surf 3 was introduced. It had all the same features of the first Pocket Surf, but a little bit more. It really allowed for 4 selectable parameters. It had RA, roughness average, but also provided RA and Rmax, which was maximum roughness depth depending on whether it was the ANSI or the DIN parameter. And this allowed people to get an easy to look at burr or scratch control parameter. So it kind of told you that there was a burr or a deep scratch. If it gave you a high number, something was wrong with that surface. It also provided RZ, which was a mean roughness depth, with kind of a cutting depth parameter. So again, a little bit more versatility with the Pocket Surf. So now you can see, kind of get the idea why it was called Pocket Surf 3, because there was a switch position on there for choosing one of these 3 parameter settings. It also had 3 selectable traverse lengths, so you can choose to take how many readings within the trace for your results. It provided RA in only in micro-inches and inches. And you may think to yourself, well, what happened to Pocket Surf 2? Well, the key thing here was that Pocket Surf 3 had the 3 parameter settings, and so we skipped over Pocket Surf 2 with Pocket Surf 3. So again, in the 90s, Pocket Surf 3 was introduced. It had the same basic shape and form and features as the initial Pocket Surf. And I think one of the key things is that you can see that the start button was moved from the front of the product to more along the middle. And that gave the product a little bit more stability when the start button was being pressed to start making a measurement. It was really over one of the V's or one of the feet, so it provided a lot more stable operation. Had the 3 parameter settings, selectable inches or metric. It had selectable cutoff lengths, and we added data output to it so that now you can start recording the values from the Pocket Surf 3. We kept the 4 positions for the probe, and of course, just like the previous, you can use it horizontally, vertically, upside down, any way you want to use it. Just place it on the part, and you can make a measurement. Plus, we also gave an H or an L indication if the values seemed to be too high or too low for the system. So great improvements for the Pocket Surf 3. But you can imagine that we have a new product doing more features, but really the applications haven't changed that much. And if you look at the stands and pictures and photos from the initial Pocket Surf introduction brochures, they're all the same pictures and applications that we have today. So whether we're measuring parts on the machine or in a stand or grooves or small parts, we still maintain all those same accessories today. And in 2014, we introduced Pocket Surf 4. There was really nothing wrong with Pocket Surf 3, but things change, electronics change, and some electronic parts become obsolete or tough to get. So it was time to update the electronics, and we did that with Pocket Surf 4. It has all the same features, same easiest to use, simple 1-button operation, the 4 probe orientation. It uses all the same probes and stands and mounting accessories as the Pocket Surf and Pocket Surf 3, the same parameters, and the same operating parameters. But we did make some improvements. Instead of having the old calibration by screwdriver, we did calibration by a digital method today. So that makes it a little bit more accurate and less chance of damaging the system by pushing a small screwdriver through a hole in the side of the product. So it makes it a little bit more robust. We also changed the output connector to be like some of the other Mahr products, like the Rmax and our 2000 series comparators, so that there's a standard cable and it can be used with Marcom now. So a great way of getting data out of the product. We made the battery cable a little bit more robust, and inserted a strain relief that prevents breaking if being pulled on when changing the battery. And you have the ability to look at the other parameters after you've made a measurement. So you can make your measurement, look at the RA value, and then switch the product to Rmax or RZ within 7 seconds, and you'll be able to see those values. So if you don't have to measure up to 3 traces to get the 3 results. You can do that with 1. All new features for the Pocket Surf 4. And all the performance specifications are the same with Pocket Surf 1, 3, or 4. We have the same measuring ranges. The valuation lengths are the same. Probe speeds are the same. So over the years, nothing has changed, and that's why customers really like the Pocket Surf product, because it's been so stable and it's packed with so many features. Like I said, the accessories really haven't changed. So these are the same accessories we've had in the past. These are model numbers for these products. So you can see there's a little stand that allows us to hold cylindrical parts and measure the surface roughness across the top. We have a small portable height stand for mounting the Pocket Surf, great for being used on surface plates, moving it around and so forth. We have a bore adapter kit so that you can help align the Pocket Surf in a portable application to like bores in the engine blocks and so forth for small to large holes. A V adapter for portable use across things like crankshafts and so forth when you can't get a stand to that application. Plus we have a universal stand where it acts as its own reference, and you can angle the Pocket Surf to virtually any orientation to get the proper surface finish alignment. There's a small bottom plate accessory, so you can use it as a portable way of measuring very small diameter shafts. We have a nice mounting bracket for use with say the 814 height gauges as a way of using the Pocket Surf on surface plate applications. And we have another portable stand that has a swivel built into it, again, for measuring and getting the right orientation of taper type parts. All these accessories have been around since the introduction of the Pocket Surf. We also have some nice output or connectivity accessories with using our Mahr Connect and USB ready cabling, where we can take the data and connect it with a USB connector or the RS-232 connector. And of course, we offer free Marcom software to take this data from the Pocket Surf and put it into Excel or any other Microsoft-based product. The probes and so forth have all been the same. We have our general probe, which comes in a 5 micron or a 10 micron radius. and those also come with the two kits that are available. We'll talk about those in a moment. We have probes for going across the part when we're used in the 90 or 180 degree position. So this allows us to ride over crowns, like in the crankshaft application. We have chisel probes. We're using the probes in the other orientation to hit that crown. We have a small bore probe, and we have a groove bottom probe. Again, all of these are mostly available in the 5 or 10 micron radius diamond contacts. Now, let's see if we can just show you this small little video here of the pocket surf being used. We notice that it's a mobile surface finish device. Typical application would be for use in production, right at the point of manufacture. The part could be cleaned off, and the ideal application is to put the pocket soap right on the part at the point of manufacture. Simple to operate, single button operation. Take your trace, get your results. Or the pocket surf can be used at the point of manufacture and the part being brought to the pocket surf. Again, an on-the-spot check of surface finish. We talked about the single button operation, start button, large display to get your results, simple switches. There's no menus or anything to work your way through. These are all available with a fixed switch, choosing inch and metric for your parameters and for your cutoff settings. And of course, the probe can be used in any one of the 4 positions. Our 0 degree position, 90, 180, and 270. So this greatly increases the versatility of the product. So depending on the type of part, you can choose the right orientation and get the results that you need. Traverse probe on the crankshafts, different stands, ability to measure small diameters. Important features that uses a standard 9-volt battery. Get 2,500 cycles for that. Use Mahr Connect to record and store your measurements. So it's a complete roughness measuring system when you purchase it. You get the pocket surf, the test specimen, battery, and a small calibration stand with it. So Pocket Surf 4 is mobile, capable of doing lots of different applications, built for the workshop. We've sold tens of thousands over the years, and it's built in Providence, Rhode Island. I think you'll find it one of the easiest portable surface finish devices to use. It's really special this month because it's the March product of the month, and we're offering it at a special value price of $2,200. It comes in 2 versions. Basically, the difference is the probe that comes along with it, either a 10 or a 5 micron probe. Both systems come with the certified reference specimen that's traceable to NIST. So you get a complete package in a nice storage case, ready to be used after you insert the battery. And people ask, which one should I use? Should I buy the pocket surf with the 10 micron radius or the one with the 5 micron radius. Well, in the States, it seems like the most common one is the 10 micron or the 4/10 radius. This comes again, they both come with the certified reference specimen, but this radius is the most commonly used in the United States for a lot of surface finish testing. If these are products that might be made and manufactured and used throughout the world, well, it might be best to invest in the 5 micron or the 2/10 radius probe, and you might get just a little bit better correlation between testing if you're comparing to results made somewhere else in the world. But primarily the 4/10 version is the one that's most commonly sold here in the States. So as part of the product of the month, we have a special data sheet that's available that talks about the 2 models that are available, some of the nice features of the Pocket Surf 4, notes the special pricing, and if you buy it this month, not only do you get it at the $2,200 price, but you also get a free Mahr mug with the purchase. We also have a 6-page brochure available should you require that, and we'll make that available through the follow-up email from this webinar. Great time to take advantage of the Pocket Surf 4. So today we learned the importance of measuring surface finish. The Pocket Surf 4 is our basic and easiest to use roughness measuring system. It can be used portable at the point of manufacture on the part, or the part can be brought to the Pocket Surf for benchtop applications. It's the simplest choice for inspection of surface finish at the point of manufacture. And it's especially great now, being the Mahr product of the month. It's a super value. And why choose Mahr for your measuring need? Well, Mahr has a broad product range for industrial metrology. We have the application competence to support you. We have a great portfolio of wireless hand tools that help you collect data and reach Industry 4.0. We have some promotional prices, especially with the Pocket Surf 4 being product of the month, and this gives you the best quality to achieve your value. After this webinar, we're going to email you a link to recording of this webinar, send you the product of the month data sheet, and offer you the brochure if you would like. So thank you for your attention. Don't be afraid to take advantage of Mahr's special offer at $2,200. I think the Pocket Surf 4 is a great investment. Thank you for your time, and glad to have you here with our webinar.